So if you think of Wi-Fi networks and you think of cellular networks, that's another kind of contrast, right? Cellular networks are structured to provide communication um, from end to end between two clients. So it's kind of a little different than client server. You have two connected people and they're communicating by voice or by video. It could be FaceTime or the Google app or Teams. So when you're dealing with communication um, interests, you'll find that networks are structured differently and managed differently than if they're data-centered networks for computing environments. So computing environments, communication environments, kind of two different animals. And I just wanted to call that out. Any questions? Are there any questions based on what we just shared?
Actually, Dr. Kensop, I do have a question about the assignment, the new
Yeah, let's
assignment that's
hold,
due on the
okay,
14th.
all right, whoa. So let's hold assignment questions for later, to the end of the
Okay,
class, okay? We have a
alrighty.
limited time to cover a certain amount, and I really want to make sure we get that covered. So we will get to that
Okay,
right before we stop. Just pop in again and unmute your mic. And thanks for understanding that. Okay,
all right, we'll do.
so there's more detail about the end-to-end concept for communications, right? And the types of management and protocol interests that are in play. The idea of a best effort packet, right? I said if you drop a video, if you drop a video packet and it's a thousandth of a second to the human eye, that's not discernible, as opposed to the other method where you're delivering an email message and it's dreadfully serious, and you know everybody has to um, everybody has to make sure they're reading the same email message from start to finish. So the sequence of the packets has to be there. You have to guarantee that all the packets for the email message are there. That's not a best effort packet transport. That's a mission critical packet transport. So once again, UDP is associated with this type of network resource or network service, communications based. And the TCP is the other type. So I do want to call out the fact that for a good part of this module, we're dealing with the industry standards. And so you're going to see references to the application layer without layers 6 and 7, like you do in the OSI model. All right, so let me update my when we talk about the transport layer protocols, you have challenges and issues like congestion. You have to be able to detect if something is missing or lost, right? When there's mismatches between speeds for the sender and the receiver. So I mean, this is just common sense in a manner of speaking. You can have a 5G wireless phone, but that doesn't mean the towers are 5G, right? We did mention sequence numbers. That helps us keep packets in order. And if there are errors, then there's a way to retransmit things if that becomes necessary. UDP and TCP, it's really important that you understand the primary differences between those two network protocols on the transport layer. Both UDP and TCP happen on layer 4. So once you have two IP network hosts that want to send and receive data, in order for that to happen, you have to move up to the layer 4 and work some protocol or other on layer 4. And once again, the universe is kind of split into two different halves: the UDP side, best effort, and the TCP guaranteed delivery, mission critical kind of protocol. Typically speaking, for most internet and data applications, TCP is required in order for the software to work correctly. If it's media and entertainment or communication, you can flip into UDP mode. We did say that DNS is it's got two different animals. So when DNS is being provided as a resource to hosts that are browsing the internet and they're getting information on how do I find myjam.net or whatever, then it's UDP that's being used to deliver that information. And if it's missing a packet, it just sends it again, because it's such a small amount of information. If you're talking about sending updates for the DNS server to tell everybody where to find those things, if it's authoritative, between DNS servers, it's TCP. But it's on the same port 53. You're going to want to know that port by heart by the end of this semester. Okay, so user datagram protocol. So one way to look at UDP, or remember that UDP has to do with demand scenarios, is that the word user is in the mix, right? So everybody hang on a sec here. Turn my phone down to. So communications for users, what's the most common protocol that's used? UDP. Why? Because the word user is literally in there. Does everybody understand what I'm saying?
Yeah.
Okay, user communications. And then when you talk about TCP, transport control protocol, that's where you have to deliver guaranteed, the word control. So for voice, right, and some video applications, if you have, it says accounts for less than 10% of internet traffic, that number is changing dramatically each year. The amount of voice and video traffic now on the internet is probably twice that. Some internet service providers block those applications. They don't want you to use them. And that's internet service providers who sell telephone service. They don't want you to use voice and video if you could otherwise buy phone service from them. And that is a reality that still exists in some places. So when we say there's a session between the host and the system that's providing the resource, right, the client and the server, you don't have a connection, but it is an end-to-end stream of data. And that's a subtle but important distinction. So the data is flowing back and forth from one end to the other between the host that needs the information and the server that's providing the information. But it's not a formal connection. It says here arbitrary interaction. So what do we mean by that? You could have multiple DNS servers, multiple email servers, and a lot of times when you're getting streaming content, you're getting it from more than one system. So just remember that packets can travel different paths, each of the packets themselves. And then when they get to the other end, they reassemble. There's fewer controls, so there's no congestion or flow control. The server typically just, think of a fire hose, right? What happens to the water after it leaves the fire hose? Well, it'll do what water does. So when we say no congestion or flow control, UDP characteristics, think fire hose, right? And where does the water go when it comes out of the fire hose? Well, generally where you aim it, but once it hits something, it can go anywhere, right? The good news is that with UDP, you can interoperate between different types of operating systems with ease. So you can have Linux-based systems or Macs or Androids or Windows, and the data can flow without consequence between those hosts. So that's one of the advantages of UDP over TCP. If TCP is in the mix, you have to have very strict modules and functions in the communications stack for that guaranteed delivery to happen. And if you're working on different types of operating systems, the commands are different. The code may be written in a different way because you have different APIs. I hope that makes sense, right? So if you're doing TCP between different types of operating system, that's trickier to pull off. So sending and receiving is pretty straightforward. When we say that something is connectionless, we mean you're sending a message to any receiver. You can send it at any time, and you can stop sending at any time. A sender doesn't inform the network before sending. The sender just sends it, right? And so those are the differences between UDP and TCP also. When you are sending something with TCP, there's a lot of signaling back and forth to make sure that things happen in a very strict sequence to guarantee delivery, right? So when you have a connection, you inform the sender and the receiver inform each other, hey, there's nothing else further. But that's not the case for UDP. They just stop sending it. It's a lot less overhead. Put another way, delivering data using UDP is much more efficient, much faster, much simpler, less trouble prone, because there aren't as many moving parts. You're just putting it out there and other people are receiving it. So in terms of forming a session to communicate between hosts on a network, you can think of UDP as kind of like a first grade level or grade school level communication. And then when you talk about TCP, you're looking at high school or university campus, right? Much more serious. A lot of the rest of the detail in here, I would encourage you to have a quick look at it. It talks about the different sizes of payloads and how there are specific limitations to the size of a UDP packet, right? And I want you to notice that I just said packet, but on transport layer, we don't call it a packet anymore. Whenever we're dealing with UDP or TCP, once the TCP packet is unloaded and the payload is taken out of that packet, what you have at layer 4 is called a datagram. So I just caught myself there. You can tell that in my 25 years of industry experience, I worked a good bit more on the layer 3 network data delivery side of the house. But yeah, when you start getting into how applications work to deliver that information, layers 4 through 7 or 4 through 5 are datagrams. We've already mentioned fragmentation. If you have a large chunk of data, but on the other end, it has to be small, you have to break that packet down, and that creates overhead or or efficiency challenges. That's true regardless of the protocol or level. You can have fragmentation with layer 2 with frames, or layer 3 with packets, or at layer 4 and higher. So does everybody remember syntax versus semantics? Does everybody remember that?
Not exactly.
Yeah.
Right. When you have a communications protocol, syntax has to do with one set of criteria. Semantics has to do with a lot of mechanics, right? So when you have datagrams or packets that are lost or duplicated or delivered out of order, you know, the sequencing and delivery, error correction, those are semantics. What are referred to as semantics. So this could get very thick in the weeds if we continue our review based on the slides, but I did want to call out some of the specifics from the slides. You should fully review all of the information about UDP and the information that follows about TCP. In the reference called Computer Networks, I don't know, yeah, online it's called Internetworking Concepts, Comer. That's the reference in the module. It's in there with the flip side of the DNS and primary application types by layer 4. The functional aspect of an internet application, and this is where the rubber meets the road. On layer 4, you have to have this connection, and the connection is formed with sockets. When you're creating applications that do this, you're working with the socket API. Is everyone familiar with the acronym API? Would anyone care to volunteer what those initials stand for? So this is just a refresher of the computer architecture. What sits between the application software and the hardware? What layer sits between applications and all the hardware on the bottom? Operating system. Hello? Everybody knows that at the top you have applications that users work with, and then on the bottom you have hardware, and what big layer sits in between is called the operating system. Is that a familiar idea for everyone? Can someone unmute your mic and let me know you're still breathing? You don't have to answer the question. I just need to know that we're still in connection.
Yeah.
Okay. So in the operating system, they have an application programming interface. These are operating system modules that allow you to create software to interact with your operating system and hardware. Whenever you see the initials API, we're talking about resources in the operating system that allow you to work down through into the hardware. You have network interfaces that have to create a socket. If you have a session that's created between two hosts, the socket is actually, both sockets are separated by a comma. So that should be something in the study guide, earlier in the study guide that we've already seen, right? Everybody remember this? We went over this a couple of days ago. When a session is created between two hosts, usually a client and a server, the socket that has the high port number is usually the client. The socket that has the low port number is usually the server, because a server is advertising, hey, I've got web pages. Hey, come here for your email. Hey, here's your Netflix video, right? So that's what we mean. So it's a nice summary of the differences. So I took this from the slides and found the two slides that summarize how it is that UDP works and how it is that TCP works. So when you're working with TCP, most of the applications, networking applications that people use with computers or computing devices require a connection, right? In order to have complete reliability, you have communication in both directions and you have lots of error control. One of the things that's a constant problem for, and we're going to cover this in our last module, one of the problems with TCP is that you form a connection, and if you're not careful and you're using the API, you have to close the socket afterwards. The last step that you should take when you're working with TCP is that you're creating a socket to connect between the two systems, but then after this connection is in place, if you disconnect from the internet, you should close the socket. And if you don't, you have a case where more and more memory and computing power is being taken up. And this is what makes systems slow. You can have a lot of poorly written communications or data applications on a network. They're created, and it's all about getting the resources you need. But the last and final step is to close the socket. Has anyone ever heard of the term zero out? It's considered a best practice when you're finishing, when you're writing statements, you're coding for an application. It's considered good form where you zero out, because it closes out your memory registers, it takes out the trash, so to speak. Has anyone ever heard the term? No? Okay, well, in Java, in Python and C and most programming languages, when you're finished writing the statements out for a given module or function, one of the things that's considered a universal best practice is zeroing out your resources so that you return those resources to the operating system. And that's another common error for novice programmers. Just remember that if you want a client server application that streams data both ways across a persistent connection with guaranteed delivery of packets in a highly structured and secureable session, then you're talking TCP. But if you just need bulk content delivered, then UDP. And that's the most important thing. Okay, let's take a brief pause and let's talk about firewalls for a bit. Can each of you, how many of you have Windows machines open right now?
Me.
Okay.
Yeah.
Is there anyone that's viewing from like a Android phone or something? Or a Mac?
Like,
Yeah.
Okay. Well, all right, so let's see if we can generalize this enough where it's good for everybody. But if you're on a Windows machine, what I want you to do is to follow along when I get to the view of the firewall interface in Windows. There's a lot of misconceptions about a firewall and what it does. So you have to understand that when you're connected to a public network, there can be bad exposures. And if you're connecting, if you're forming a connection in a session so that you can use a common internet application like email or a web, you want your browser to work with web pages. That's an internet application, right? So the simple truth is you're making those connections on known ports, but there's a lot of network applications, gaming in particular. Do we have any network gaming fans in the audience?
Me.
Anybody?
Me.
Nobody in the class does network-based gaming online?
Me. Me.
Okay. I mean, aren't half the Xbox and PlayStation games out there rigged for multiplayer, multi-user, right?
Yeah. So.
Okay. Well, one of the things that you have to understand is that if a server has a socket open and it's listening, it's opening a port and it's coordinating with a network security device called a firewall. Now, one of the images that's problematic with that term, when you think of a wall and you think of a physical firewall, you get the idea that the fire is blocked from traveling in one direction or the other, right? And in digital terms on a network, it's only inbound network traffic that's typically blocked. Now, you can configure a firewall so that it blocks outbound traffic, but most users don't do that. And most system providers, most operating systems don't do that. Put another way, if you're trying to connect with a resource out on the internet, your firewall is going to open the appropriate ports or associated ports for that application. Port 80 for a website, port 25 for email. A firewall only blocks unauthorized or unwanted inbound network data. Inbound. That means that somebody on the outside on the internet wants to connect to your system and get in your Kool-Aid. And a firewall is intended to block inbound. So if you're following along, you can get to the firewall by going through settings or through control panel and scrolling down to Windows Defender Firewall. And if you look at the settings, the advanced settings, it's the inbound rules that are typically the most important ones to watch. So if I have iTunes installed on my local machine and iTunes wants to send notices or updates inbound, I have to have a rule for iTunes. I have to have an inbound rule in order for that those data packets and connections to get through. Okay. But in the advanced mode for advanced security, you can configure outbound rules. So you can turn off a port, and a lot of you are saying, well, I don't see a port here. Well, let's go to a quick example. Does everybody see file and print sharing? Let's do give me 1 second here. You can open a rule on the firewall to allow an entire application to come through, but you can also specify a specific port. So if you look at the rule by double clicking on it, and you look at the protocols and ports, in this case, TCP port 6 is used for Google Chrome. Does everybody see that? Oh,
Yeah.
no, that's the protocol number. I'm sorry. TCP connections from any port can come inbound for Chrome if Chrome is enabled. So in this case, because the application is enabled, it'll say all ports for inbound, right? So we're in the inbound rules, Google Chrome. And if we look at ports and protocols, any port can be used to create a TCP connection if the interest has to do with an application, Google Chrome. But you can also specify a specific port if you want to, like if you want to do DNS, or you want to, let's see if we have remote. Let's look at remote. Microsoft remote access, remote assistance, remote desktop. So they used to list remote desktop. They don't have it here anymore. If I create a new inbound rule, I can specify the port. So let's look at this and see. We'll say Windows remote desktop. It's port 3389. That's one of the ports in your study guide that you're supposed to know off the top of your head. RDP, or remote desktop protocol. So what do I mean by RDP? I can use the remote desktop connection to lock onto the screen and the keyboard and the mouse of a server or a system remotely. And this is the older version of it, and this is the newer version. So if I have this in play and I connect here, it's going to use 3389 to establish that connection. If the firewall is letting me connect, right? And in this case, when you get a login prompt, that means, okay, I'm connected. So you have a session. It is a connected session. Connection means TCP. Connectionless means UDP. So I can type in a password, a login, a password, and get on my screen. You got to spell it right. Can everyone see my screen?
Yeah.
Okay. Let me try this again. So here's a system that I'm accessing from St. Croix, and it's actually sitting on the east coast of the United States. And so it's establishing a remote connection through the firewall. Okay, so I get an error that says I'm already connected, you know. Essentially, when you connect and you're doing this so you can see another system from a distance, you're flowing through 3389. So I could have a case where it says, hey, it's not going to let me do this because of the firewall. In fact, let me see if I can generate that message. I took the specific port number out. You can use different port numbers if you want to. Here it says, remote access to the server is not enabled, the remote computer is turned off, or the remote computer is not available on the network. If you suspect it's the last one, that it's not available on the network, that has to do with the firewall. So you would go into here and you would say, okay, I want an inbound rule, and I'm going to use a port, and I'm going to use TCP 3389. And when I receive packets inbound, I'll allow the connection, regardless of which firewall profile I'm using. These are for a corporate or enterprise environment like at UVI or a government agency. Private would mean you're out on the open internet, and or no, I guess it means you're in the home network. And then public would mean you're connected through public Wi-Fi, like airport Wi-Fi or hotel Wi-Fi. You can put here, I can say allows inbound connections using RDP, and that's port 3389. I hit finish, and I have a new firewall rule. If I look at the top, that's the one I just created, and it uses port 3389. So you just watch me create a firewall rule to allow a connection where otherwise, if somebody tried to connect, they'd say, oh, it's not available on the network. It's not available on the network because the firewall is blocking it. Ordinarily, we don't have a built-in remote desktop rule. We used to have one. They don't like people using remote desktop because it can be a significant security challenge. The important thing to understand is that firewalls only typically block inbound connections that are unsolicited or unwanted or unauthorized. But when it comes to outbound, if the user is trying to connect to something out on the internet, a firewall doesn't do anything. Let's say that again. If the user is connecting from their system to a public system, that's outbound. A firewall will not prevent a connection with a malicious system or an infected system, an unauthorized system, on that basis. Okay, we'll stop here for today.